So now let's discuss some other properties of logarithms. And one really important aspect of being able to evaluate a logarithm is just our ability to rewrite logarithmic expressions in a simpler form. We've actually already used a few basic properties. I'll give you a few examples. We've already said things like this. If we take a logarithm, base a of a, we're going to get 1. We know that because a to the first is equal to itself. We know that if we take the logarithm base a of 1, we're going to get 0. Some other properties, well, there is this inverse property that said if we take a logarithm base a of the quantity a to the x, we're going to get x. And, by the way, we also stated that if we were to take a and raise it to the logarithm base a of x, these are inverse functions, they'll undo each other and leave us with x again. So that's not too bad. Well, what about these guys? Well, there are 3 important properties of logarithms other than these that we really need to know. So if a is a positive number, a is a positive base, and a is not equal to 1, right, then if n is a real number, we can say some of these following rules are true. The first one gives us something about a product. It tells us that if we have a logarithm of a product of 2 different numbers, then we can split it apart as a sum. So the logarithm of a product is equal to the sum of the logarithms. And just a quick example of that first one right here, let's talk about a logarithm base 2 of the quantity 2x. That can actually be simplified because remember 2x means 2 times x. So by this rule, that's equivalent to saying the logarithm base 2 of 2 plus the logarithm base 2 of x. Now, of course, using our property above here at top, we could actually rewrite this one more time to simplify this as 1 plus the logarithm base 2 of x. Why 1? Well, sure, right? The logarithm base 2 of 2 would equal 1 by this property at top. All right, here's another rule. It tells us that if we take the logarithm of a quotient of 2 functions, it's equal to the difference of the logarithm. So the logarithm of u divided by v is the same thing as the logarithm base a of u minus the logarithm base a of v. Again, another useful property. For example, we could run into problems where we want to deal with a logarithm. Let's deal with a logarithm base 10. Let's call it a common logarithm. A logarithm base 10 of something like, let's try 10 over x plus 1. For some reason, we have a logarithm that comes out this way. What could we say about it? Well, it's really going to be the same thing as taking the logarithm base 10 of 10 minus, in this case, because we're subtracting, the logarithm of the quantity x plus 1. Now note, we don't have any rules that tells us that we can do anything else with this logarithm. It stays. It's the logarithm of the quantity x plus 1. X and 1 are joined by addition. There's no rule to split that apart. However, this very first term is pretty good because it's another example of our property right here that the logarithm base a of a is equal to 1. So rewriting this one more time, this is really like saying 1 minus our logarithm, our common logarithm, base 10, of the quantity x plus 1. Okay, one more rule. This is our power rule. The power rule says that if we have a logarithm base a of some quantity u to the n, it's going to be the same as taking that exponent n and multiplying it by the logarithm base a of u. Good example of this one. Well, let's try this. What if we had a natural log? This is a logarithm base e of x to the third. Well, by this rule, that x to the third can be broken up as 3 times the natural logarithm of x. That's pretty good, right? That changes exponents into multiplication, which is useful for us, and we'll find out how in the upcoming video.